As experienced software engineers, we know that perfect software is the enemy of good, secure, and profitable software. But when should we upgrade or update the dependency packages in our tech stack? Keeping in mind that we have to balance delivering new features and managing technical debt among many other things during each sprint cycle. Software engineering teams using full stack JavaScript or TypeScript know all too well how important updating and upgrading dependencies are. This is because historically, the JavaScript ecosystem has moved much faster than, say, Python or Python, C Sharp or Java. One of the reasons for this is because originally the JavaScript standard library was very small when compared to other programming languages. So the JavaScript development community built millions of tiny packages, which are NPM packages, to suit their needs. When one small NPM package changes or becomes deprecated, it can have a ripple effect downstream. Another reason is that unlike Java, which is owned by Oracle, or C Sharp, which is owned by Microsoft, JavaScript has no corporate ownership. Oracle only owned the trademark to the JavaScript name, only the name. They do not own nor control the JavaScript language itself. JavaScript is actually standardized by ECMA International, more specifically, the ECMA 262 standard, controlled by Technical Committee 39 or TC 39 within ECMA International. But the ecosystem is driven by massive competing tech giants, Meta, Google, Vercel, Amazon, or Amazon, to name but a few, are all pulling in different direction to suit their cloud or product needs. This competition accelerates change. By the way, Google and Meta are current member of TC39. Let's circle back to where we started and answer the question that I posed. When should we update or upgrade our tech stack dependencies? Allow me to suggest the approach that has worked out well for me. First and foremost, when there is a gaping security hole. For example, the denial of service vulnerability in an older version of Express.js, which is a library for Node.js, or the NPM supply chain compromise in certain NPM packages that happened in September of 2025. These two examples are no-brainers. If you work for an organization that has a cybersecurity department, they're usually on top of these things. But for smaller dev shops, the software engineers are responsible for advising upper management of this and fixing the issue ASAP. Another indicator for me is if the version of a certain library or framework that you're using is so old that it affects your team's productivity. If one of your engineers develop a proof of concept application that is based on your production code, but on an experimental Git branch and can prove that the newer version of a certain library can cut 25% or more in development time for future tasks, but maintain the same level of security, then it's worth the upgrade to me. The flip side of the coin is that we don't want vanity updates or upgrades or chasing the quote unquote new hotness in whatever technology. We should be upgrading to a version that is well tested and supported in terms of knowledge base. I hope this video has given you some food for thought. If it was helpful, please consider subscribing to my channel and give this video a thumbs up. It is completely free. Thank you for watching. I'll see you next time. Goodbye for now.